The Kutta-Joukowski leaf theorem. Leaf theorem. The cylinder flows with circulation as shown before in previous video. Develop an invisible downward lift. We have invisible downward lift normal to the free stream. Called the Magnus-Robbins force. This lift is proportional to the stream velocity and the vortex strength, so this lift force proportional to the stream velocity and vortex strength. Its discovery by experiment has long been attributed to the German physicist Gustav Magnus, whose opposite, let me write, was observed in the 19th century. It is now that the brilliant British engineer Benjamin Robbins first reported a lift force on a spinning body in 18th century. We see from the streamline patterns that the velocity on top of cylinder is less, and thus from Bernoulli's equation the pressure is higher. On the bottom we see tightly packed streamline, high velocity and low pressure. Low pressure viscosity is neglected also. Invisible theory predicts this force. The surface velocity from Bernoulli equations. Neglecting gravity, the surface pressure is given by this relation. We have for Bernoulli with neglecting the gravity effect, so we have P and U infinity is S squared. PS can be obtained as this relation: infinity plus 1 second on for sinus square theta for beta sinus theta minus beta 2. Where K on and P infinity is the free stream pressure. If P is the circular depth, so if P is cylinder depth, into the paper, the drag D is the integral over the surface of the horizontal component of pressure force on the circle, pressure force PS minus P environment BA d theta PdA, where PS minus P infinity is substituted for the pressure, but the integral of cosinus theta times any power of sinus theta over a full cycle 2 pi is identically 0. Thus, we obtain the results. The drag is 0. So we can make a result that according to indice theory the drag of any body of any shape immersed in a uniform stream is identically 0. D'Alembert published these results in 18th century and pointed out himself that it did not square with the fact that real fluid flows. The unfortunate paradox caused everyone to overreact and reject our indice theory until the 20th century, when Prandtl first pointed out the profound effect of the thin viscous boundary layer on the flow pattern in the rear, as Chapter 7 described. For example, the lift force L normal to the stream taken positive upward is given by the summation of vertical pressure forces, which obtained from this relation for lift force sinus theta d theta. Since the integral over 2 pi of any odd power of sinus theta is 0, only the third term in the parentheses contributed to the lift, so we can this relation for the lift force. We have a relation for Ps minus P infinity from Bernoulli relation, U infinity a square 4k on BA from 0 to sinus a square theta. So we have this relation for the lift force. Two pi b. With the simplification, the final expression for the lift force is lift force on the depth of the cylinder, density of fluid, upstream velocity multiplied to the circulation. Note that the lift seems independent of the radius A of cylinder. Independent of the radius A. Of the cylinder, actually, though, as we shall see in the previous section, the circulation gamma depends on the body size and the orientation through a physical requirement. We can have a result for the lift force. According to indice theory, the lift per unit depth of any cylinder of any shape immersed in a uniform stream. Let me write here according to the indice theory. The lift per unit depth of any cylinder of any shape immersed in a uniform stream equals to multiply to the circulation, where circulation is the total net circulation contained with a body shape. Containing within the body shape. The direction of the lift is 19 degrees from the stream direction. From the stream, let me pass the line, the stream direction, rotating opposite to the circulation. To the circulation.